Greetings and salutations, everybody. This is Jacob. So, how the heck do we go about solving this problem? It seems bewildering. Just start from the beginning, my friend. The journey of 1,000 miles starts with one step, as they say. Not with 50 steps, not with 30, not with 20, not even with 5. Just one. Put one foot forward, and then the other foot forward, and so on and so forth. Luis. Okay, let's look at this diagram here. So the radius of this big circle here is r, as we said in the initial conditions. But what about this radius here, of the smaller circles? We'll call them r2. And we'll call r1 the radius of the circle whose circumference touches the radii of the smaller circles. So r equals r1 plus r2, naturally, my friends. Okay, what about this angle here, theta? That looks at the circle segment of the R1 circle that is within one of the smaller circles. Since we're dealing with 10 smaller circles, this angle here is 360 over 10, which is 36 degrees. Since all the smaller circles are of equal size, correct? Okay, so now what do we do? Let's find the length of this chord here that the 36-degree angle is looking at. And this length is given by the formula L equals 2 times r times sine of theta over 2. Where r is the radius of the circle and theta is the angle. Since r equals r1 in this case, and theta equals 36 degrees, we have L equals 2 times r1 times sine of 18 degrees, which is 0.618 times r1. And looking at this diagram here, we have r1 equals d1 plus d2, where d1 is the distance from the center of the bigger circle to this chord here, and d2 is the distance from the smaller circle's center to the chord. And these two distances bisect this chord, meaning they cut it in half, since everything is symmetrical here. And we'll find d1 and d2 accordingly, starting with d1. By the Pythagorean theorem, we have d1 squared equals r1 squared minus 0.618 times r1 over 2 squared, which is r1 squared minus 0.09 times r1 squared, which is 0.91 r1 squared, which is 0.954 times r1. Now we go to d2. d2 is just the difference between the radius of this medium circle, r1, minus d1. So now we have d2 equals r1 minus d1, which is r1 minus 0.954 times r1, which is 0.046 times r1. Now that we know these two distances, let's find this angle here, theta, which is tangent of theta equals 0.3 times r1 over 0.046 times r1, and the r1's cancel out. And we have tangent of theta equals 6.52, which is theta equals arctangent of 6.52, which is approximately 81.28 degrees. So the total angle that looks to this chord here from the center of the smaller circles is 81.28 times 2, which is 162.56 degrees. And since this chord's length is already known in terms of r1, we use the formula for the chord's length again. And we have 0.618 times r1 equals 2 times r2 times sine of 162.56 over 2, which is 2 times sine of 81.28 over 0.618 times r2. And we get r1 equals 3.2 times r2. So now let's put r2 and r1 in terms of the bigger circle. So we have r equals r1 plus r2, which is 3.2 times r2 plus r2. Is 4.2 times r2, and we have r2 equals r over 4.2. And we use this equation again, and this time we solve for r1, and we end up with r1 equals 0.761 times r. So now we put these radii in terms of the bigger circle's radius. Now what do we do? This total area here is this area plus this area, correct? And if you recall the formula for the area of a circle segment, it's A equals theta times pi over 360 minus sine of theta over 2 times r squared. We'll call this area here A1 and this area A2. And so we have A1 equals 162.56 times pi over 360 minus sine of 162.56 degrees over 2 times r2 squared, which is 1.417 minus 0.15 times r over 4.2 squared, which is 1.267 times r squared over 17.64. And we end up with A1 equals 0.071 times r squared. And A2 is 36 times pi over 360 minus sine of 36 over 2 times r1 squared, which is 0.314 minus 0.2935 times 0.58 r squared. And we end up with 0.011 times r squared. And now, so this total area here that is highlighted is 10 times A1 plus A2, which is 10 times 0.071 r squared plus 0.011 r squared. And we end up with 0.82 times r squared. Now we're prepared to find the shaded area that the problem is asking for, which is A of S equals the total area of this circle here, this medium circle, which is pi times r1 squared minus 10 times a1 plus a2, which is 3.14 times 0.761 r squared minus 0.82 times r squared, which is 1.818 times r squared minus 0.82 times r squared, which is approximately r squared. 0.998 times r squared to be exact, but not even this is exact because we've been rounding up and down so far. And that's all she wrote, my friends. That's your answer. Luis, r squared is this shaded area here, which is counterintuitive, that it's almost exactly r squared, but that's math for you, my friends. It's beautiful in unexpected ways. Luis. So that was a fun geometry puzzle, wasn't it? My guys and gals, this one was easier than the previous two problems that I posted. A refreshing change of pace. Luis. This one has a nice balance of difficulty, either too difficult or too easy, either too hot or too cold, just right, as Goldilocks would say. Right in that meaty part of the bell curve, my dudes. So the preparation of this video went smoothly for once in quite a while. No redoing calculations or rewriting scripts over and over again. None of that nonsense. Oh no. Part of the challenge of conjuring up your own problems is not knowing beforehand how difficult a problem will end up being. You might end up with something that's too easy, or you might end up writing a dissertation, of course. Of course, if it's too easy or too difficult, you can tweak the initial conditions a bit. Much like when you're cooking, for example, if the food needs more salt, then you throw in more salt as needed. But once in a while, you'll conjure up a problem whose initial conditions seem perfect. You don't want to tweak it because it'll water down the problem too much. But then the solution of such problem is too difficult. Those are the problems that are hard to deal with. So it's hard to strike a nice balance of stating a problem eloquently and simply in the problem statement, or the initial conditions, if you want to call it that, and a solution that's not too hard or too easy. I mean, if you dabbled in problem posing yourself, then you know exactly what I'm talking about, my friends. So that's pretty much it. I hope you liked this puzzle. Comment down below what you think. If you found it too difficult, if you solved it another way, smash those buttons like they owe you money. Shoot a puzzle suggestion my way, and I'll see you guys in the next video. Bye-bye.